explain about special relativity as simple as possible for everyone to understand. Special relativity is actually dealing with the time dilation or the expansion in size of somebody. Now, what is the basic of special relativity is that special relativity is mainly based on the constant speed of light. What the constant speed of light is actually is I'll explain in a simple example. Take a moving train. Taking a moving train now, imagine a person standing inside the train which is moving with some velocity v. Now this person will put some torch so that the light will travel. So now, according to general physics, the velocity of light should be equal to v1 is equal to c plus v. Now here c is the speed of light, that is 3 into 10 power 8 meters per second. This is what according to general physics is, but according to the nature or what special relativity says about constant speed of light is that even if the train is traveling with velocity v, this won't get added up with the speed of light. That is, the speed of light remains same, even it remains like c itself. Even in the moving train, it doesn't change with the velocity of the moving train or whatever. So whatever the thing you go up or you travel, the velocity of light is constant. Pause. So now the velocity of light is constant. So this is what the basic thing of special relativity is. Now we'll go to see what actually the time dilation is. The time dilation. For this, I'll just take one simple example, the same example, like the moving train now in the opposite direction. Just consider these two persons inside the train moving with velocity v, and imagine it's totally dark inside the train, and this person puts on some torch to see this person. So the light travels in this direction with the velocity c. So now the velocity of light is constant c. So now this is one part of what I'm saying, and the other part, imagine it's a normal thing with no velocity. It's like zero velocity outside somewhere in the your home or somewhere where you are still, there is no motion. The same scenario, and now he puts on the torch and it moves with velocity. So now the only difference between these two things is that this is in the moving train and this is at still position. So now what happens is that here I'll just put a graph. Like here in this condition, the distance that the light should travel is greater than the distance here the light should travel. The only reason for that is this person is moving with velocity v, so he is always changing his position. So according to change in his position, the velocity of light should be compensated. It's just like saying the velocity of light is constant. It like here it's the greater distance that it has to travel, but here it's the lesser distance that it has to travel. So now we'll take this is the distance d. D1 for this scenario, d1, and this is d2. This is d2. But whatever the distance, the greater distance it has covered should be compensated by the time, that is v is equal to d by t. I'll take this scenario, like for example, for this guy the time slows down. The time slows down just to make the speed of light constant. I mean, if the time slows down, the light has much time to travel this larger distance. So for this, t2 is greater, that is t2 is greater, and it slows down. The clock moves very slow, so that this light has more time to travel this larger distance, whereas here it takes t time or t1 whatever, but it travels a distance which is equal to here what we have taken here, and this time is like the normal time we are watching. But for this guy the time slows down, and that the reason is that here the constant speed of light should have to travel larger distance, because this guy is changing his position. If the velocity of light was c plus v, it would have taken the same time what this scenario has taken. But since this velocity is not added up, the constant speed of light, because of constant speed of light, this v is cancelled off. So this light has to travel larger distance than the light traveling here. So this distance, larger distance, should take the same time. So for that, the time should slow down so that it should take the same time as here to travel this distance. So this is what makes the time dilation for this guy. This is all the special relativity is about.